this video, I'm going to show you some more on plotting. Not as much as I would have liked to, because it occurred to me as I was trying to write this script that a lot of what you need to know about plotting doesn't make sense until you've learned the underlying statistical procedures that you need to do to plug in to the plot, to create the plot. But I will take you through some basics and then kind of show, I've got some examples of stuff that I've done to kind of show you like where we're going with this or where we'll be able to apply it eventually. So the packages we're going to use are going to be Rio to import the data, and then ggplot, of course. Here you're going to want to change this to whatever your data set is named. And then this other data here is some built-in data within R that's kind of called toy data that is kind of widely used to show examples of stuff. I'm using that in addition to our data just because I want to show you the difference, some differences between the two. So if you get those imported, this empty cars data, you actually have to come over and click on this for some reason. I don't know why, but to get it to pop into there as a data set, it won't until you do that. The next thing here, I have this function here. So go ahead and run that and create that. You don't really need to so much understand what all this is right now. Just know that what the function does is scale any variable so that any interval variable so that it ranges from 0 to 1. And so we want to scale then this income variable to this new variable income scaled. And that'll make sense a little further down why we need that. So we're basically just going to focus on scatter plots today because we didn't really do those in the previous lectures. So it is the same basic structure. You're going to have the ggplot function. You're going to tell it to what data set to use, and then this AES or static command that we give it an X and a Y value. Except this time we're now going to be using geom point instead of geom bar or geom histogram. And then I just threw in there a color. You can throw in there whatever color you want. So what you're going to wind up with is this. And what I chose for the X variable was income gap perception, and then Y variable, the capital feeling thermometer. So we get this, you know, with plots, it plots all the points on here. The empty cars example uses vehicle weight and miles per gallon as the X and Y variables. And if you run that one, you're going to see it looks just a little bit different than the one that we just were looking at with our data, the AES data. And that's because even though these are even though they're both interval variables, we only have discrete values for income gap perception. We don't have anything that is in between 1 and 2, anything that's between 2 and 3, 3 and 4, etc. So that used to freak me out. Like I do a plot and I would be expecting to see something like this, and then I get something like this, and I think that I did something wrong, but it's just because of what your data looks like. The weights of the cars are in thousands of pounds, I think. Not tons, I don't think. I think it's thousands of pounds. So you see you got like 2.62, 2.87, 5. So you have these, you know, a bunch of different values that are in between these ticks on the graph, on the x-axis there. So we can actually also color the points on the graph by another variable. So in our data, I added this color equals factor female. And if you run that, you'll see that you get, you know, the same thing as far as where the points are, except for now you have two different colors, one for male, which is the zeros, and one for female, which is the ones, and this aqua color. It's also throwing this NA out. We're going to ignore that for now because there's some lines of code that you have to run that actually kind of pull from the tidyverse language to get rid of that. And since I haven't really showed you anything in Tidyverse, we're just gonna like pretend those aren't there. I will ultimately do a Tidyverse video, I think I've decided, because I just don't like it, but that doesn't mean I should probably not at least give you guys a tour of the language of Tidyverse, because, and let you make your own decision on whether or not you like it. Because like I said, some people love it. It just does not speak to me. So if we want to run this other one, here we see that it's colored by cylinder. So you've got, you know, this kind of makes sense. The 8-cylinder ones are down here in the corner. They're more heavy. 6 cylinders are in the middle, and the 4 cylinders are down here. They're the lighter vehicles. Also better on gas, which again makes sense. So we can also change the size of the points to whatever you want. You can make them bigger, which I'll do with our example here, or you can make them smaller, which I can show you with the empty cars example. You can also make the size of the points dependent on another variable. So this is where that scaled income comes into play. So I'm just gonna put in regular income and show you what happens, because we have values that are like 350 and, you know, 225 or something like that. So you get this really weird looking thing. So if you scale it so it's just between 0 and 1, then you get this like more useful way of looking at the data. It's the bigger points. You can still tell that the bigger points are the higher income, the lower ones are the lower income, but it doesn't take up the whole stinking graph. The empty cars example has them sized by type of transmission, automatic or manual, which is kind of less intuitive than like the big ones. I don't know which one is which. 0 is automatic or 1 is manual, or vice versa. So that's like not a great variable, I would say, to use for this particular thing, but that's what I pulled this example actually from somewhere else. That's what they had. So you can also change the shape of the points instead of the color, depending on a particular variable. So in this one, instead of changing the color between male and female, we're going to change the shape. So you've got triangles versus circles. And if you run the empty cars example, it uses triangles and circles and squares, depending on the type or number of cylinders. Or instead of varying the color or shape, you can actually put them on separate graphs with this facet wrap argument. And this little tilde here is kind of important. Easy to forget. So here you've got this stupid little NA that I can't show you how to get rid of just yet. And then you've got all of the females on one graph and all the males on another. And same thing over here. This one's actually gonna spit out also 3 graphs, but like one that actually has points on each of them. 8-cylinder, 6-cylinder, 4-cylinder. We can also add a regression line, which if you have had if you've seen regression before, you know what this is. If you don't, we'll get to that soon, I believe. But this line is kind of makes sense that it would be going this direction if you figure that people who perceive the income gap to be larger are probably less warm about capitalists than people who don't perceive it to have gotten larger. This was probably not an easy to guess from how these dots played out in this particular example, but probably on this other one, you know, it was a little easier to assume that we were going to see a line that went went like this, went this direction. Finally, we can change the labels, like I've shown you already before too, with this LABS argument. Title equals X equals Y equals. You can change the title, give it a title, and change the labels for the X and Y axis. And then the same thing over here with this one. So that's it. Really, like I said, it's kind of hard to give additional examples until we actually have some analysis that makes sense to us. But I did, let me see, let's start with this one. So this is from the CCES, which is another national survey that I used to look at support for felon voting and support for offender diversion in the criminal justice system. So basically sentence reform. So this one is going to be a bar graph. So this is the tidyverse stuff that I was talking about to get rid of the NAs, which I'll show you eventually, I promise. But then here's just the regular ggplot function and the AES with the X and the Y stuff here. It doesn't have the data set right here because I used this tidyverse format. So that's one of the differences between tidyverse and base R. But the rest of the stuff then stays the same. So you've got the AES, you've got the X and the Y, and then you have a bunch of different arguments that add different things to the graph. So geom bar, so it's going to be a bar graph. And then I gave it a theme, and then just all this different stuff, which, you know, some of it I don't even remember what it does. This puts the legend at the bottom. Clearly, this throws a title on there. This adjusts the font size of the title. And then I didn't want an X and a Y label for some reason or other. I think because I don't remember. But anyways, this is actually the X and Y limit, then of course, and then this has to do with throwing up the legend on there, what the legend labels are, and telling it to only give it two values. But anyways, this is the end product here. And basically what it's telling you is, here's the legend down here. I put the A and the S in this graph as well. But so gray is Republican. This is the percentage of Republicans that oppose felon voting. This is the percentage that favors it, and percentage of Democrats that favor felon voting, percentage that oppose it, which, you know, all of this kind of makes sense. And then the same thing again down here with support for diverting offenders or sentence reform. Another example I wanted to show you, just because it's the point, it's a geom point, which kind of like puts into context what I was just showing you above, except for not in a scatter plot format. This is actually going to be just single points with error bars on them. So Rick talked about in class last week about how we usually have a confidence interval where there's like a plus or minus. We think it's going to be this value plus or minus something. And so that's what this argument does, is actually puts those bars on the graph. And then, yeah, I'm not going to go through all of this stuff. Also, this looks different. This isn't a regular regression. It's an ordinal regression, I think. And so what this is calculating is the marginal difference between one category and another. And this is the resulting plot from that. So you see we got the points here. It plots these points, and then it puts these bars on here to show the confidence intervals. And what this one is saying, if you care, is The difference, the change in probability of favoring felon voting if you've been arrested versus if you've never been arrested. So if you've been arrested, at least in the full population, if you've been arrested, you're roughly 7.5% more likely to favor felon voting than if you had not been arrested. And then for Democrats, you're about 6% more likely. Republicans, you're about 8.5-ish% more likely. This might seem weird to you, that Republicans would be higher than Democrats, but if you figure Democrats tend to favor felon voting to begin with, or at least we associate them with more progressive policies when it comes to criminal justice, then they didn't really have very far to move. Whereas Republicans probably did not support it very much in the beginning, and then if they're arrested, then that changes their viewpoint, makes them more likely to support it. So that's all I have on plotting. We'll touch on that quite a bit more as we progress through the semester, and you've actually learned the underlying statistical analysis that support that.